The ArcGIS platform allows for a complete end-to-end drone workflow, from planning and capturing with purpose-built field applications to processing, managing, and analyzing with purpose-built desktop applications, as well as cloud processing, and finally to disseminating and collaborating with the ArcGIS platform that you've all been seeing today. All of this aims to quickly and easily handle drone data so you can gain its insights. Let's take a look now. Now to the plan and capture phase. With the new site scan for ArcGIS field app, I can create accurate drone flight paths from within the field. What's really cool about this app is that it can bring in your own ArcGIS operational layers into the app to give context to what you're flying. In this case, I want to bring in a new proposed paddock, and then I will match up my flight path to the boundary of where this new paddock might be going. I can also adjust settings on the left there, such as altitude and hatch angle. And notice at the bottom, there are a bunch of metrics that update as I move the flight area around, such as how long the flight might take, its expected resolution, and how many batteries that flight might need. All really useful information to have out in the field. Once I'm happy with where I want to fly my drone, I can simply hit fly, and my drone will take off autonomously and complete its intended flight path. All of this is aimed to take the level of entry out of drone data capture, as well as reducing any human error from manually flying a flight path. And eventually, it'll improve data quality as well as consistency of capture for your drone image data. Now to the process, analyze, and disseminate phase. As previously mentioned, the ArcGIS platform has intuitive drone-specific applications aimed to quickly process your imagery. From there, you want to do something useful with the imagery, such as perform measurements of area and volume, maybe some more in-depth analysis with calculations, as well as high detailed inspections of your newly captured imagery of your farm. And of course, we finally want to share that imagery with people that need to see it, such as within your organization or key stakeholders. Let's take a look at a demo now. So now I'm back in the office. I've completed my drone flight. I've uploaded all of my imagery, in this case to SiteScan for ArcGIS in the cloud, where it has processed and auto-rectified my imagery all for me. This same workflow could be achieved with Drone2Map, our desktop application as well. Here I can view all the images I captured during my flight. But now I want to gain some insight from my recently captured imagery. So we'll conduct a few measurements. Here we can conduct simple line measurements to see how long my new fence is, as well as inspect individual photos if I wanted to get up close with my recent fence build. If I click on a spot on the new imagery, it brings up all of the raw images that contain that same spot. Here I can load up a raw image and really get in close to see what my fence really looks like. We can also conduct area and volume measurements. If we wanted to measure a stockpile, for example, we could simply draw over the stockpile and get an accurate 3D measurement of the cut fill of that stockpile to really see how much is there. In this case, we have an accurate measurement of some bushes and some rocks to see how much volume that contains, as well as the area of how big that is. And of course, who doesn't love a good bit of 3D? Here we can view that same volume calculation, in this case visualized in a 3D measurement, to really get a gauge of what's in the cut and what's in the fill of this volume measurement. We can also generate 3D point clouds, which are great for 3D measurements such as the height of this bank, for example, or it could be more important 3D objects in your farm, such as stockyards, for example. All the same measurements are available here, in this case in 3D. And also an automatically generated 3D mesh for awesome visualization of your farm in 3D. So you can really start to build a digital twin of your farm. The ArcGIS platform can also handle full motion video that you capture in the field. This is great for visualizing and surveying hard to reach areas such as gullies and riparian zones. You can also bring this same video into the ArcGIS desktop application, ArcGIS Pro, where you can visualize that same video and mark locations directly onto the map, as well as conduct measurements. And finally, to the disseminate and collaborate phase. I've now shared that same imagery directly to ArcGIS Online. Now, with an up-to-date picture of my farm, I can share the same imagery with the rest of my workers to be able to view in the field in our field apps that you've been seeing today. This same imagery can then be shared with key stakeholders or people that need to see a survey of an area. However, in this case, we want to keep the workflow going a bit by building a simple viewer and editor application. With this same imagery, I can use editing tools now to mark out exactly where the new fence actually got built. I've also noticed that there's something not quite right in the paddock. So I'm going to create a quick feature noting that an inspection is required here. This same inspection feature will then be passed on to our field workers using apps such as Collector that you've seen today to be able to complete the workflow. This has been a really quick overview of the complete drone workflow in the ArcGIS platform. Hopefully you've seen how quick and easy it is to use the platform to gain valuable insights for your organization from drone imagery.
James has given us a detailed look at the drone capture, processing, and dissemination using ArcGIS. But now let's take a look at how we can analyze and use drone captured imagery to answer important questions about our farm or our orchard. So how do you get started, and how do you make the most out of purchasing a drone? Ground-based and aerial-based drones are used widely in agriculture, as many of you will already know. They can be used to enhance various agricultural practices like crop health, irrigation, crop monitoring and spraying, planting, and soil and field analysis. Improving and understanding these processes really does depend on the sensor on board the drone. That is, the quality of spectral and spatial resolution of the camera. A UAV can be mounted with types of sensors like an RGB camera or an infrared camera. It could be hyperspectral, which would help enable the identification of specific plants and minerals. Or it could be multispectral, which arguably is revolutionizing agriculture by, for example, enabling farmers to easily identify stressed areas of a crop. And then you also have your thermal, your LiDAR, and your radar sensors. The reason for using one or another really comes down to what you want to get out of it. Is it for a specific task at hand that requires detailed information? Or is it to meet economic expectations? That is, get your return on investment. So what are the pros and cons of these sensors, and how can we analyze the imagery results to help farmers make beneficial decisions? Dr. Deepak Pudjal and the team at Esri Australia have put together a great list of some of the most common problems and subsequent imagery analysis outputs that farmers ask about. Now let's take a look at a couple of these. The first is pretty fundamental. I have a huge orchard and I have a large number of citrus trees, and I want to automatically count how many trees I have. This isn't a task that can be done manually. An infrared camera mounted drone can be used to capture this information about the citrus orchard. Now, in addition to this, I might want to know the position and the size of individual plants in a field, and this can be used to increase the accuracy of future yield predictions. Individual trees can be automatically counted from this imagery. You can see them circled in red in the image here. This is showing their location and their size. Moving now to the health of these citrus plants. Individual tree health can be derived and represented through different colours, as you can see here. So we can see that green represents healthy plants, whereas red are less healthy, and you've got your yellow and orange plants that are in between. And now taking that a step further, we can look to analyse which zones within this large field might require attention or are experiencing stress. In this image, derived using hotspot analysis, green areas represent trees that are doing better than average. Red are less than average, and again that yellow neutral colour is in between. So we can easily see the spatial discrepancy of the health of our plants. Now these are just a few of the questions that can be answered by analysing drone captured imagery with ArcGIS applications and tools. It may be for counting crops across a large area and monitoring the health of individual plants. This would help farmers make better decisions on crop inputs such as fertiliser or pest control. But ultimately, it all comes down to the accuracy, as this is the key to productive, usable, and worthwhile outputs. Thanks to Esri Australia for sharing the use cases, and thanks to everyone for watching.